Before we move on to the next theory article, we'll solve a few simple basic level numericals. Here comes the first one. The equation of a stationary wave is given by y is equal to 0.05, y is equal to 0.05 cos 2 pi x sine 100 pi t. The equation of the stationary wave is given. Okay. Find the distance between its nodes. उनके नोड्स के बीच का डिस्टेंस, नोड्स के बीच का डिस्टेंस कितना होता है? लैम्बडा बाय 2. So you have to find the distance between the nodes, means you have to find lambda by 2. Distance between the nodes and amplitude at antinodes. You have to find the amplitude at antinodes. क्योंकि हर पार्टिकल का एम्पलीट्यूड अलग होता है ना? ये एंटीनोड है, तो यहाँ पर मैक्सिमम एम्पलीट्यूड है, यहाँ पर एम्पलीट्यूड कम है, यहाँ पर एम्पलीट्यूड और कम है. Every particle is having different amplitude. You have to find the amplitude at antinodes. Okay. Also find the amplitude at 20 centimeter from one end. Amplitude at x is equal to 20 centimeter. Amplitude at antinodes and amplitude at x equal to 20 centimeter. This is the complete question. Now look at this equation. Compare it with the equation of a stationary wave. क्या थी equation of a stationary wave? Y is equal to 2a cos 2 pi x by lambda sine 2 pi t by t. Do you remember this? This is amplitude of stationary wave and this is the phase. Now comparing this, you have to find lambda. So first you'll have to bring this equation in this form. इस equation को इस form में लाओ. Y is equal to 0.05 as it is. Cos 2 pi x by lambda. Cos 2 pi x by 1. 2 pi x is 2 pi x by 1. Sin हमको चाहिए 2 pi t by t, तो इसको हम लिखेंगे 2 into 50 pi t. चलेगा? 100 pi t is 2 into 50 pi t. So this will become 0.05 cos 2 pi x by 1 sin 2 pi t upon 1 by 50. So now this equation is in this form. अब दोनों को कंपेयर करो. 2a की जगह पर है 0.05, means 2a is equal to 0.05 और a is equal to 0.025. एक वैल्यू मिल गई. 2 pi x by 1, 2 pi x by lambda, means lambda is equal to 1 meter. So lambda is equal to 1 meter, or capital T is equal to 1 by 50. Periodic time is equal to 1 by 50 second, or you can say frequency is equal to 50 hertz. अब हमसे पूछा क्या क्या है उसने? Find the distance between its nodes. Distance between its nodes means lambda by 2. Lambda is 1, so 1 by 2, that is 0.5 meter. You got the first answer. Distance between the nodes lambda by 2 is 0.5 meter. आगे क्या पूछा है? Amplitude at antinodes. Antinodes पर amplitude होती है plus or minus 2a, isn't it? Maximum amplitude, and 2a we found that is 0.05. 5. So amplitude at antinodes is plus or minus 0.05 meter. That is your second answer. और क्या पूछा है उसने? एम्पलीट्यूड एट एक्स इक्वल टू 20 सेंटीमीटर. ये है एम्पलीट्यूड का जनरल फॉर्मूला, है ना. कैपिटल ए इज 2a cos 2 pi x बाय लैम्डा, जो कि यहां पर है 0.05 cos 2 pi x. This is the amplitude at any point. Amplitude at antinodes 2a. Amplitude at any point 2a cos 2 pi x by lambda. This is amplitude at any point. Now put the values here. This will be equal to 0.05 cos 2 pi into x is given to be 20 centimeter, that is 0.2 meter, that is equal to 0.05 cos 2 into 0.2, 0.4 pi. 0.4 pi मतलब कितना? 0.4 pi. Pi is 180 degree. So 4 8s are 32, carry 3. 4 1s are 4 plus 3 72, or 18 4s are 72. So this is equal to 0.05 cos 72 degree. Cos of 72 degree, you can see from your log table. Multiply it with 0.05. That will be your last answer. Two waves of amplitude 2 centimeter. दो वेव्स हैं, हर वेव का एम्पलीट्यूड है 2 सेंटीमीटर. फ्रीक्वेंसी 1200 हर्ट्ज. n is equal to 1200 hertz and traveling with a speed of 300 meter per second. V is equal to 300 meter per second. Combine to form a stationary wave. इन दोनों वेव्स का सुपरपोजिशन हुआ and a stationary wave was formed. Find the distance between two adjacent antinodes. Means lambda by 2 is equal to what? And maximum speed of the particle at antinodes. Vmax is equal to what? At antinodes. What does this mean? If you consider a stationary wave, every particle is performing simple harmonic motion, and in simple harmonic motion the speed is maximum at the mean position. तो हर पार्टिकल का स्पीड मैक्सिमम कहां पर होगा? मीन पोजीशन पर. एवरी पार्टिकल हैज मैक्सिमम स्पीड एट इट्स मीन पोजीशन, है ना. ये पार्टिकल सपोज ऐसे वाइब्रेट हो रहा है, सिंपल हार्मोनिक मोशन, इसकी स्पीड मैक्सिमम यहां पर होगी. So every particle is having maximum speed at its mean position. You have to find the maximum speed at antinode. Antinode वाला जो particle है, उसकी maximum speed कितनी होगी? So first you have to find lambda by 2. You are given amplitude, frequency and velocity. So lambda is equal to V by N. That is equal to velocity is 300 and n is 1200. That is equal to 1 by 4 meter, because velocity is in meter, or you can say 0.25 meter. So lambda, the wavelength, is 0.25 meter. You have to find the distance between antinodes. Lambda by 2 is 0.25 by 2. That is equal to 0.125 meter. So you got your first answer. The distance between two antinodes is 0.125 meter. Maximum velocity at antinodes. Vmax in SHM is A omega. Remember this? From oscillation, maximum velocity is A omega. A is the amplitude. कौन सा amplitude? At एंटीनोड कितना होगा वो 2a. So a means 2a into omega is 2 pi n, that is equal to 2 into a is 2 centimeter, means 2 into 10 raised to minus 2 meter into 2 pi into n is 1200. Multiply this, you will get the maximum velocity at antinode in meter per second. Clear? A string is vibrating in its first overtone. String is having first overtone, means which harmonic? Second harmonic. First overtone of a string is equal to second harmonic, that is 2n. Means number of loops or harmonic number is equal to 2. The string is in its first overtone, means it is second harmonic. It is second harmonic, means p is equal to 2. Okay. Between two supports 1.6 meter apart, the string is vibrating between two supports, which is 1.6 meter apart, means length of the string. The vibrating length of the string is 1.6 meter. Further, it says find the distance between node and antinodes close to it. Node and antinode close to it means lambda by 4 is equal to what? एक नोड और अगले एंटीनोड के बीच का डिस्टेंस, that is lambda by 4. Very simple. In the different modes of vibration of a string, I gave you a general formula. Lambda is equal to 2L by P, isn't it? When the number of loops is more than 1, or whatever is the number of loops, lambda is 2L by P. So directly putting the values, 2 into L is 1.6 upon P, the number of loops is 2. So lambda is 1.6 meter, because this is in meter. So lambda by 4, distance between node and antinode, will be equal to 1.6 by 4, that is equal to 0.4 meter. Simple. A wire of length 0.5 meter, a wire of length 0.5 meter is stretched by a weight of 2 kg. Its tension is 2 kg weight. The tension is given in kg weight, that is equal to 2 into 9.8, that is 19.6 Newton. It is stretched with the help of 2 kg weight, means the tension is 2 into 9.8, that is 19.6 Newton. Its mass per unit length of the wire, if mass per unit length of the wire, that is small m, is given to be 1.96 into 10 raised to minus 3 kg per meter. Find the fundamental frequency of the wire. N is equal to what? And frequency of its first overtone, means N1 is equal to what? Fundamental frequency and first overtone. Very, very, very simple. Direct question it is. N is equal to fundamental frequency 1 upon 2L under root T by M, that is equal to 1 upon 2 into L is 0.5 meter under root tension is 19.6 upon mass per unit length 1.96 into 10 raised to minus 3. So this is 1s are 10s are 1.96, 19.6, 10 means 10 raised to 1 plus 3, that is 10 raised to 4. So this is 1 upon 2 into 0.5, 1 into under root 10 raised to 4. Under root 10 raised to 4 is 10 raised to 2, that is 100. So frequency is 100 hertz. First answer, the fundamental frequency. First overtone N1 in string is equal to second harmonic. So N1 will be 2 into 100, that is 200 hertz. You got both the answers. Two wires of the same material, two wires are having same material, means their densities are same, means rho 1 is equal to rho 2 is equal to say rho. Their materials are same, means their densities are same. So two wires of the same material and having same diameters, D1 is equal to D2 is equal to D, or you can say R1 is equal to R2 is equal to R. Their diameters are same, means their radii are same. Have their length in the ratio 1:3. L1 upon L2 is equal to 1 upon 3. Their lengths are in the ratio 1:3. And under tensions in the ratio 1:4. It's P1 upon P2 is equal to 1 upon 4. Compare their fundamental frequencies, means N1 upon N2 is equal to what? Compare their fundamental frequency. Here, we are not using this for overtone. N1 means fundamental frequency of the first wire, N2 means fundamental frequency of the second wire. This is not first and second overtone. So, N equal to hota hai 1 upon 2L under root T by M. If you remember, this M, mass per unit length, mass upon length, we wrote it as rho pi r square, and you can say N is equal to 1 upon 2L into R square बाहर आया under root T upon rho pi. Now you can put the values. That is equal to 1 upon, or sorry, not put the values. We have to find the ratio. So N is equal to, अब देखो दोनों में same क्या क्या है. 2 is a constant, lengths are different, radii are same, means R is a constant, tensions are different, densities are same, pi is a constant, means N will be proportional to root T upon L. Simple हो गया अब. So N1 upon N2 will be equal to under root T1 upon T2 into L2 upon L1. That is equal to under root T1 upon T2 is 1 by 4 into L2 upon L1 is 3 upon 1. So N1 upon N2 will be equal to 3 upon 4 का square root है 2. So their fundamental frequencies are in the ratio 3:2. आज यहीं पे रुकते हैं. Rest of the things we shall see in the next lecture. So have a nice time. Good day. Bye bye.